Hello, hi. This brief overview video of dipole interactions with electric fields is inspired by the paper by Arrondo et al. Okay, so what is a dipole? So a dipole is two opposite charges separated by some distance. And the interaction will depend on the orientation with respect to an electric field. Okay, so in very basic terms, a dipole is two opposite charges, a negative charge and a positive charge, separated by some distance. So the distance d would be just the physical distance from here to the positive pole, and an interaction between the dipole moment and electric field will depend on the orientation of the molecule or dipole moment in space with respect to the electric field and the angles created and the torque resulting from the angle. Okay, so we know that electromagnetic waves propagate in one direction, and the oscillation of the magnetic field relative to the electric field is at a 90-degree angle. Okay, we also know the electric field component of infrared radiation will oscillate in one direction at the frequency of the radiation, and the attempted coupling with the dipole is as a result of the torque exerted on the charges of the dipole. Okay, so in terms of resonance and vibration modes, for the infrared to be absorbed, the vibration of the molecule must cause a periodic change in the dipole moment, and when the frequency of the infrared matches the natural vibrational frequency of a molecular bond energy. Energy is absorbed, and there is an increase in the amplitude of the vibrational motion. So you might be familiar with the concept of constructive interference. So if we know that if the frequency of one wave matches the frequency of a second wave, we will have a constructive interference effect, and the total amplitude will equal the amplitude of our first wave and our second wave.